Hello, hello, hello. Oh, hello, Mike.
Morning. Anyone hear me? Someone's groaning. Anyone hear me?
I can hear you, Mike.
Yeah,
Good.
I can hear you.
I don't know if you can hear me, but
Who was that?
that is Dominic.
Hi, Dom. Yeah, got you. Jake? Can't hear you, Jake.
Oh, come on, Jake.
Hello?
Hello.
Hello?
Who's...
Hello?
Hello. Who's that?
Taylor?
Hi, Tyler.
What is it as well?
Nathan's here.
Oh, that's better. Morning, Nathan.
This is so weird.
Right. Who we got missing?
Jake Honey.
Can you hear us, Jake?
I don't know if they press the thing in the bottom left where you put the audio on.
Jake, I don't know if you can hear us, but you've got your audio muted. Got your microphone muted.
There we go.
All right, Jake? Can you hear us?
There we go. I'll have a bit of me.
Hello, Dom. Right, so we can hear you, Dom. Your mic is muted, Taylor, for some reason. Can you hear? We got you, Nathan. Yeah.
Yeah.
Got you, Jake. Yeah.
Oh,
Yeah. Yeah. I'm just confirming that you can hear us. That's all.
yeah.
Yeah. Right, we're just about ready to start then, I think. Don't know what's happening with all the others, but all we can do is press on. Right. We'll share. Have you got your handout all right?
Yeah.
Okay then. So what we're going to look at today is adding, alternating waveform phasors to determine a resultant. So some of this will feel a little bit similar because we've been doing work with phasors or with vectors in maths as well. This is maths, but we've been doing vector work in electrical as well. So if you have an alternating waveform, that's in the sine omega t form vectors, and then with a phase angle, you can add phasors to get a resultant waveform. So there's a number of methods we can use, and we're going to have a look at each of these, some of them in more detail than others in the session today. So we're going to look at plotting the waveform and adding them graphically. That's with the Desmos software. And perhaps have a go at that later if there's time, or between now and next week, by drawing the phasors and measuring the resultant, which we've already had a little bit of a look at anyway. But I want to go over that again because where I was attempted in science, that weren't really done the best. By using cosine and sine rules, so that's like the cosine and sine rules for non-right angle triangles, using horizontal and vertical components, which we've already had a look at in part, and by using complex numbers, which is probably the easiest way if you're confident with those. So everybody all right with that?
Yep.
Yeah.
Good. I'll move on. So first of all, I'm just going to talk through this at the moment, and then perhaps we'll have a go at it later. Graph plotting software. So what you can do with software like the online Desmos is to plot two waveforms separately and then add them together so they're on the same axis. And then you can look at the important ordinates, so you can find out what the peak of the resultant is by clicking on the graph, and you can find out what the phase shift is. And if you just look at the next slide in your handout, you'll see I've done two waveforms there. So if you just keep an eye on my cursor, these are the three. So it's a plot a graph of y1 is equal to 3 sine A between 0 and 360. On the same axis, y2 is 2 cos A. So the red one is 3 sine X. The blue one is 2 cos X. Sine X and cos X are 90 degrees out of phase with each other. So you can see that the sine X crosses at 0 and the cosine is at peak when the angle's 0. And then I plotted the third y graph, y3, is those two functions added together. You can do that in Desmos. All right. Then what I've pointed out here is that you could, this point, black point here, is the peak of the resultant waveform, which is green, and we can find the y-axis value is going to be the peak. So 3.606 is the peak of the resultant waveform. And then to get the phase angle, we're looking for what is the green waveform, the resultant, relevant to the one that crosses at 0, so the red one. We can see that it's leading because it peaks before the red one, and we can take that point here, 180 on the x-axis, this point here, take this 146.31 away from 180 to get the phase angle, the resultant. So this is picking out that detail here. The peak is 3.606. The angle of phase shift is 36.69 leading. So we could write an expression for the resultant as 3.606 sine brackets x plus 33.69. So that's the normal form of a waveform. So that could be one way that we could add to two or more sinusoidal waveforms together and find the resultant. Is everybody happy with that?
Yeah.
If you look over here, I just pointed out that in Desmos you can switch between, if you go into the settings, click the the spanner icon, you can switch between the what is the standard radians, dealing with angles to degrees if you want to. This would also equally work if you had your angles in radians anyway. Okay.
Yep.
Everybody happy with that? And there'll be hopefully be a chance to have a go at that a bit later.
Yep.
Okay. So
Yep.
again, I'm gonna just talk through one thing I need you to do, something I noticed when I was checking through all this yesterday. I had y1 down as 3 and y2 down as 4. I've switched them over because the drawing I'd done the opposite way round. So if we look at this, my scale is 2 units on the drawing to 1 on the phasor. So if I move that ruler up there, 3, that should be 3 there. I thought I changed that yesterday, but never mind. 3 and 4. So y1 is 3, y2 is 4. So I've extended that to 6 centimeters because that's representing 3. Yeah. And this one down here is at an angle of 60 degrees. Yeah. And it's 6 centimeters long, more or less. Okay. And then what I'm trying to get across here is the accuracy that you can do this to, bearing in mind that you're drawing. We can then put our ruler on the resultant waveform after drawing it in. We can measure that off. Measure that off as 12.4 units. Get the ruler in the right place. Yeah, so we got a half that figure. We get 6.2 units for the length of that line, and the angle is approximately 35 degrees. You should bear in mind, if you're using this method, that you can really only go to 2 significant figures. A lot depends on what scale you use and how accurately you can measure it. How big you draw it is a key thing as well. So you want to try and make it as big as you can on the page if you use that method. All okay with that?
Mm-hmm. Yep.
Yep.
Yeah.
Yeah.
Right. You can all still hear me okay?
Yep.
Yeah.
Yeah.
Right. Now, next thing we're going to have a look at is determining the resultant using sine and cosine rules. So have you got your notes in front of you? Because I'm going to switch to a whiteboard so I can write on it now. It's a little bit tricky.
Is this handout on Moodle?
Sorry?
Is this handout on Moodle?
It is, Dom, yeah.
Right.
No, hang on, sorry. I sent it to you, I think.
Oh, right. Okay,
I sent it to you yesterday.
Oh, okay, yeah.
By the way, all of you, before it happens, Omal and I had a bit of a practice yesterday, and we found out that the 40-minute limit is brutal. It just switches off, no chance to save and everything. So about 35-minute mark, I'll be switching to a second, a new room. All right?
Yep.
The details are the same.
Yep.
I'm going to try and fit that in around you having a go at something and then come back, but we don't know exactly how long we're going to take to do anything. That's the trouble. All right, so have you all got that that in front of you in some way so you can follow what I'm doing? Yep.
Yeah.
Yeah.
I'm going to stop the share of that and share a whiteboard. Right, we've got this triangle. These two vectors. Y1 is 5 at angle 0. So that one's 5. And then Y2 is 4. And there's an angle of pi over 6 between, yeah, or 30 degrees. We'll probably work with 30 degrees for now. Okay. So we can add, the best way to look at this is to draw those two vectors out using the nose to tail method. So there's Y1, that's 5 long. Let's write that here. And then at 30 degrees down, we draw Y2, which is 4. And there's our resultant in there. Yeah. And we know that this angle in here is 30 degrees. Okay? Yep.
Yeah.
Yeah.
So,
Yep.
first of all, using the cosine rule, which is a squared, I'm just doing the standard form. Does that look familiar?
Yeah.
Yeah.
I think it's,
So what we can do is say that the resultant squared, so that's this line, R, is equal to B squared, so that's the 5 line here, plus 4 squared minus, put some brackets in, 2 times 5 times 4 times cos of the angle 30 degrees. Yeah.
Yeah.
Sorry, 100. We can't do 30 degrees. 1 minute, boys. Gone wrong there. Rubber. That's this angle in here. That's the opposite angle, which is, that's 30. It's going to be 150. Yeah. All right. So that's how you would do that. Do you all see where that come from?
Yeah.
Mm-hmm.
What have I done now?
I just lost all that. Oh, got it.
I touched something with my wrist. Clear button. Right. Need to be careful of that. So we can say 5 squared is 25. 4 squared is 16. 2 times 5 times 4 times cos minus 150 comes out at, if you check that in your calculator, 34.641. Yep.
Mm-hmm.
Is that a minus sign in front of the 34?
Yeah, that is, yeah. So the two negative times make a plus. If we do all of that, we end up with 75.641. But that's r squared is equal to that.
That's
So we
the square root.
take r as root 75.641. Yeah, which is 8.697. Yeah.
Yeah.
Okay with that?
Yeah, I think that way's quite
Yep.
easy.
Right. Let me just save that. Because I don't think I'm going to fit the other bit on this. I'm going to put a new page up. what I'll do with these pages is I'll add them to the normal whiteboard slides with the problem, and then they will be put up on Moodle as well as a after the session set of notes.
Yeah.
Okay.
That'd be good. Cheers.
Right, second page. So then to find, to determine the angle, I'm going to use the sine rule. Which is the sine rule is we're going to use R of a sine 150 because that's the opposite angle is equal to 4 over the sine for the angle we're looking for, because we got this as R. We want that angle in there. Yeah. All follow that?
Yeah.
Yeah. That's the angle from 0 of the result. So we've gone with this side, R, against that 150 is equal to the length of this side, 4, over sine of that. Yeah, all follow that?
Yes.
And then we got to rearrange this. So that's an equal sign in there. So we can, we've got to bring sine theta over to the left-hand side. Yep.
Yep.
And then sine 150 can come over. So we can have R sine the angle is equal to 4 sine 150. And then finally, for sine 150 over R. Yeah, all follow. And then we can do the angle is sine to the -1 of all that. And R was 8.697. And check it please, but according to Mr. Bird, that is 13.29 degrees. We can then say, I'll do it in red down the bottom here as the final answer. We can say that R is equal to 8.697. That's the magnitude, so that's the amplitude, sine 13 sine, sorry, we've got to have omega t in there. We really should have stayed with radians here, because that is equal to 0.232 radians. Did you all follow that? Because the original waveform involved omega t, we really should have kept our angles in radians, because omega is the frequency in radians per second. Remember that, okay?
Yeah.
Mm-hmm.
All right with that so far?
Yeah, I think so.
Right. I'm going to go back to, just let me save that slide. And I'm going to hopefully stop that share now. Get used to this eventually. Oh, we got Macaulay now as well. You're with us,
Yeah.
Macaulay.
It's been here the whole time, but he hasn't had his mic on because he's insecure about his voice.
Okay, well that doesn't really matter. He's here.
Oh,
Put your hand back up again, Macaulay. Make sure I know you can hear me. Hear me, Macaulay? Good. Right. So I'm going to go back to sharing this, and on your next page, there is a problem for you to have a go at. So you got y1 as 2 sine omega t, and y2 is 3 sine omega t plus pi over 4. Yeah. So pi radians is 100. You should try and get used to these and what they are in degrees, so you can visualize. Pi is 180 degrees, so pi over 2 is 90. So pi over 4 must be 45. So using the sine and cosine rule, I'm going to say find an expression for the resultant. What we'll do is I'll give you till 5 past and then come back into a new room, same details. All right?
Yeah.
Everyone all right with that? In the meantime, I'll make sure this one is all saved up, the video and everything ready to go. Okay? So I'll open a new meeting at 5 past.
All right.
Yep.
Okay, then I'm going to stop the share now and close this meeting. All right?
Yeah.